So I hope you're starting to get into a rhythm that we're doing the same things every time. We start by factoring. Sometimes things are a little bit more complicated to factor. The bottom's already x minus 1. I personally always find it more difficult to factor a quadratic when the leading coefficient is negative. So one of the things I like to do then is just factor out the negative to begin with. If you like factoring with that negative up front, that's fine. But if I factor out that negative to begin with, I find the thing inside easier to factor. So in this case, 2x squared minus 5x plus 2, it's going to be 2x and x to get 2x squared. To get 2, I'm going to put a 2 here and a 1 there. That way my outside is 4, my inside is 1. I need them both to be negative in order for me to get a negative 5x in the middle. I quickly multiply that out just to check that it matches up. And it does. So now we've factored it completely. Step 1, figure out our vertical asymptotes or holes. We have a non-permissible value. X can't equal 1. Does that factor cancel out? No. So we know that we have a vertical asymptote at x equals 1. Step 2. Are we going to have an oblique asymptote or a horizontal asymptote? We have an oblique asymptote because we have a higher degree in our numerator. If we have an oblique asymptote, we are going to need to use synthetic division or long division to figure out what it is. In this case, since we're dividing by x minus 1, we can use synthetic division. I set up my synthetic division. My original question, -2, +5, -2. I'm dividing by x minus 1, so +1 would be out here. Bring down the -2, multiply, add, multiply, add. And my oblique asymptote, you can ignore the remainder, is -2x plus 3. So as far as my graph goes, we have a vertical asymptote at x equals 1. We have an oblique asymptote at -2x plus 3. So that means I have a y-intercept at plus 3, a slope of -2, down 2 over 1, down 2 over 1. And label that asymptote as well. Step 3, let's find our y-intercepts and our x-intercepts. Y-intercept is when x is 0. Go to your original equation, plug in 0. You'll get -2 over -1. So we have 0, 2 as our y-intercept. For our x-intercept, plug in 0 for y. Take your factored equation. Again, the only time that a fraction is equal to 0 is if that numerator is equal to 0. You can see that if you multiplied both sides by x minus 1, the x minus 1 would just disappear, and you would get it already factored equal to 0. So our x-intercepts are going to be 2, 0. That would be the second factor. And 1/2, 0. One half, 0, 2, 0. Do we need any other points? Our vertical asymptote separated our graph into two sections. We have points to the left of our vertical asymptote. We have points to the right of our vertical asymptote. We have enough information to graph this. Here, towards the asymptote, towards the asymptote. Here, towards the asymptote, towards the asymptote. Okay? I find these graphs are the most tempting to get an E10. I found it very hard myself to restrain from getting an E10. Okay? I'll show you why. I'll do the green again in purple, but with a mistake. Okay? For whatever reason, this part people have no problem going straight down closer to the asymptote. But with a diagonal asymptote, you just like to do that. You see how it's swooping away from the asymptote? Same thing here. This would be no problem, but here it's like, woo, and you just want to go to the right. Here and here would be an E10 error because you're getting farther away from the asymptote. The purpose of an asymptote is to show that your graph is getting closer and closer to that. So it needs to show that as well. And I'm serious when my whole body wanted to do that. Like it's like you just want to swoop off to the right. You want to do it quick. You want to finish your graph. And it's very, very tempting to do that. So I'm going to erase all the bad purple. There we go. Okay. Does this one ask for domain? Probably did. State the domain and the range. Here your domain, you only have one non-permissible value. X can't equal 1. And your range is everything, because it goes up and down forever. Question number 5 for practice, but we are going to do example 4 right away.